We have a, b, and z are complex numbers where the norms a and b are not equal to each other, and norms of a and b are not equal to 1. If we have this equality, then we want to find the norm of z. Okay, first let's define a, b, and z. So we'll say a is s plus ti, b is u plus vi, z is x plus yi. And here I should have said where s, t, u, v, x, y are real numbers. We want the conjugate of a and b and z. So let's do conjugate of a is s minus ti, conjugate of b is u minus vi, conjugate of z is x minus yi. And actually we don't need conjugate of z, but I just added it in there. Okay, now a, z plus b, I replace a with s plus ti, z I replace it with x plus yi, and then b I replace it with u plus vi. So I FOIL this out and I get sx minus ty plus u plus a quantity sy plus tx plus v times I. So I just separated, this part represents the real part and this part represents the imaginary part. Now I did the same thing with the conjugate of b times z plus the conjugate of a. I replaced it using these first two steps, FOILed it out, and ended up with a real part and again an imaginary part. Now az, the norm of az plus b we said is equal to this from the previous slide. So when I take the norm, what I'm doing is taking the square root of the real part plus the real part squared plus the imaginary part squared. So that's why I broke it up into the real and imaginary. So this is real, this is imaginary. Same thing with the conjugate of b times z plus a conjugate of a. Broke it up into the real squared plus the imaginary squared. And here we're given that these two are equal. So I'm going to set these two square roots equal to each other. And because they both have a square root on both sides, I square both sides. Now this step gets very complicated. So what I did was I FOILed it out and factored out a -4 from both sides. So both sides have a -4, which means you can cancel this -4. And there's a bunch of things that are going to cancel, but I skipped some steps because it gets very messy. And ultimately what we get is x squared plus y squared minus 1 times s squared plus t squared minus u squared minus v squared, and that's equal to 0. So here we have two cases, right? We either have x squared plus y squared minus 1 equals 0, or s squared plus t squared minus u squared minus v squared equals 0. But notice that the norm of a does not equal the norm of b. So recall that a is equal to s plus ti, b was u plus vi. So the norm of a is s squared plus t squared. The norm of b is u squared plus v squared. So we have norm of a does not equal norm of b. In other words, based off this thing, in other words, square root of s squared plus t squared does not equal square root of u squared plus v squared. If I square both sides, that means s squared plus t squared does not equal u squared plus v squared. And if I subtract the u squared from and the v squared, I get s squared plus t squared minus u squared minus v squared does not equal 0. Okay. So this actually does not equal 0 based off this condition right here. So really, this factor is going to equal 0 only when x squared plus y squared minus 1 equals 0. So in other words, only when x squared plus y squared equals 1. With that out of the way, we want to find the norm of z. Z, recall, was x plus yi. So if I take the norm of that, you just take x squared plus y squared, all under the square root. And note from the previous slide, we said x squared plus y squared minus 1 equals 0. That means x squared plus y squared equals 1. So I'm just going to replace 1 inside the square root, and so the norm of z is equal to 1. And that is my final answer.